Okay, we're moving on to chapter. We'd finished with the last algebra chapter, so we're moving on to chapter 14, and starting off with indices, laws of indices. Okay, so it's page 325. Now you'll see when we start off with indices, we've come across this before, and some people have had issues with it because we've never actually covered this chapter, and it has appeared in other parts. So hopefully this will clear up a few of the problems people are having. Alright, so if we look at page 325, it starts off with the laws of indices. So as we go through each of these examples, if you take down the yellow boxes that go with each of the numbers 1 to 6, and what we're going to do is we're just going to cover each of those 1 to 6. Alright, so laws of indices. There's a few different laws and you'll remember them. They are in your maths tables if you go to page 21. But they're hard to understand if you haven't actually practiced them. Okay, so this will help you remember them, but if you haven't practiced them, this isn't going to be very much help to you. Okay, so indices is another word for powers. Okay, so when you're dealing with stuff with powers, and all the things we're going to do here, the base is always going to be the same. So you can see over here we have 4 and 4, x and x. Here we have 3 and 3, a and a. Alright, so quickly, it says, the first one says, to multiply powers. So when two things are multiplied, if you look in the book, that's the same as saying 4 by 4 by 4 by 4 by 4. So how many 4s is there? There's 5. So it's 4 to the power of 5 there. So when we multiply powers, all we do is we add the powers. When we multiply bases with the same power, we just add the powers. 2 by 3 is 5. Same with here. It's going to be x, and this is 4x is x by x by x by x, and this is 2x is x by x. So altogether there's 6x's, and 4 plus 2 is 6. So when we're multiplying, we add the indices, and that's in the first yellow box. So take down that and take down the yellow box as well. Division. Division is the opposite. It's like there's 3 by 3 by 3 by 3 by 3 on the top, and 3 by 3 on the bottom, and two of those 3 on the bottom. 2 of those 3's in the bottom will cancel with 2 of the 3, so you're left with 3 to the power of 3. And division says, if you look at the yellow box, to divide powers of the same number, subtract the indices. So 3 to the 5 divided by 3 to the 2, we subtract the powers 3 to the 3. And the same way if we're using letters, a to the 7 and a to the 3, it's just going to be a to the 4. Okay, again, take down those, but also take down the yellow box. If you flip over to the next page, a power raised to a power. So this is x squared, all to be to the power 3. That's like saying x squared times x squared times x squared. And if we add all those powers, that's x6. So when you're raising a power to another power, we multiply the indices. So that's the yellow box at the top of page 326. And the same way, x to the power of 7, all to the power of 3, is x to the power of 21. Okay, there's 3 more rules to go through. Anything, we've come across this before, and again, some of you are unsure. 7 to the power of 0 is not 0, it's 1. X to the power of 0 is 1. And that comes from, if I have 7 to the power of 2 over 7 to the power of 2, what's anything divided by itself is 1. And if we follow the rules of indices, 7 to the power of 2, so that would be 2, take away 2, that would be 7 to the power of 0. So that, using the laws of indices, that's 7 to the power of 0. And knowing when we divide something by itself, it's 1. So that must equal that. But again, you don't have to remember how you get there. All you have to remember is anything to the power of 0 is 1. 7 to the power of 0, a million to the power of 0, x to the power of 0 is 1. Negative indices. Here it starts to get a tiny bit trickier. And we'll move on to trickier ones again tomorrow. 4 to the power of minus 2 is the same as saying 1 over, and again this is in the yellow box on page 326, 1 over 4 to the positive 2. And if it's a number, you could say 1 over 16, because 4 squared is 16. X to the power of minus 3 is the same as saying 1 over x to the positive 3. So when it comes below the divide sign, or the bottom of the fraction sign, it becomes positive. So if it was x to the power of minus 4, it would be equal to 1 over x to the plus 4. Again, take down that yellow box on page 326 as well. And anything, a product, so this is a times b raised to the power of 4. Each of them gets raised to the power, so it's going to be a to the 4 and b to the 4. Not just a, b to 4. Both of them, it goes to both of them. And I'll just put a line in between these two. This is not just, the answer here is not just 3a squared. It's not just the a that gets squared, it's the first part as well. So 3 squared is 9 and a squared is a squared. Okay, so just all this means that if there's two things in the bracket that are multiplied together, a product, the power applies to both of them. Here we have a to the 4, and this is the quotient. Quotient means divide. So this becomes a to the power of 4 over b to the power of 4. It just means that the 4 gets applied to both of them. And where that's more going to come up is something like this last one. And it's going to be 2a to the power of 2. So 2a to the power of 2 is 4a squared. And the bottom 3b to the power of 2 is 9b squared. And that one's finished there. Okay, so if you could take down those 6 laws and also take down the yellow boxes that accompany them on page 325 and 326. Take down the examples in the green box on page 326. Again, there's some simple examples there. And then I'll get you to do some questions. And if you have any questions, just please comment on the assignments that I set.